Today we are going to be talking about exterior angles in polygons. Our exterior angles will have a different formula than the interior angles. The sum of all of the measures of our exterior angles, our formula for that is going to be S sub E, right? Sum of the exterior angles is equal to 360. It's always equal to 360. So whenever you see the word sum and exterior, you're thinking, oh, that's got to be 360. For the one exterior angle, or each exterior angle, you're going to be using a different formula. So to find one of the angles, you'll use E is equal to 360 degrees divided by N. N is the number of sides. You can also technically use another formula if you're trying to solve for the number of sides. Let me also specify what E means. That is just one exterior angle. And S sub E up here is just sum of the exteriors. And that other formula that I just mentioned is N is equal to 360 divided by E. You can use either formula. I like to use this formula when I'm trying to figure out the number of sides. I use this formula when I'm trying to figure out one exterior angle. Okay, let's give a couple of these a shot. The first one is just talking about N as in the number of sides in our polygon. So, I'm just going to write out my formulas. For N, the sum of the exterior angles, which we learned earlier, was 180 times N minus 2. Sum of the exterior angles, which we just talked about today, is always 360. The measure of each interior angle, which again we touched on yesterday, 180 times N minus 2 all over N. Remember, N represents the number of sides. What I'm also going to do is set it equal to what we know, which is just the sum, which is just the each interior angle, which is I. Measure of each exterior angle, we're going to use 360 divided by N, and that's one exterior angle. I'm also going to put what they're equal to over here as well, just so we're very clear. Okay, so in our first problem, we're given N, right? In this column, N is 8. 8, that is the number of sides. What I'm doing in this chart is filling in each of these, measures based off of our N value. In these other couple cases, we're not given N. We're going to have to solve for N. So, I'm getting ahead of myself. Let's start with just number 8. 8 numbers of sides. So we'll do 180 times 8, because that's our N value, minus 2, which is really 180 times 6. 180 times 6 is 1080 degrees. Sum of the exterior angles is always 360 degrees. Measure of each interior angle, what we're really doing is taking this 1080 with and then dividing by the number of sides. You could also use the formula, right? But we can see that this formula is the same thing as the sum of the interior angles. So 1080 divided by 8 is 135 degrees. In each exterior angle is just 360 divided by 8. 360 divided by 8 is 45 degrees. Okay, this is where it just gets a little tricky. We're going to have to set up some equations to solve for N. Your whole goal is to get N, the number of sides. Right now in this column, right, for this polygon, we're not given it. We are given one exterior angle. So what we'll need to do is set up a formula in order to talk about what that exterior angle really means. We know based off the formula E is equal to 360 over N. E is 24. So we are going to set E of 24 equal to 360 over n. From here, we cross multiply, right? Top to bottom, bottom to top. So we have 24n is equal to 360. We divide both sides by 24 and get n is equal to 15. Okay, so we're setting up an equation to talk about this 24 degrees. So now that we have our n value, we can fill in the rest of this chart based on the number of sides. So we'll use our formula for the sum of the interior angles. So we will do 180 times 15 minus 2. And we will find that, again, that's 180 times 13. And that's equal to 2,340. Sum of the exterior, always 360. It's our fun one. And then we will take our sum of the interior angles and then divide it by the number of sides of 15. That's 156. Okay. Now here comes the 150. First off, what are we given? What are we given that this 150 is? We know 150 is the measure of each interior angle, right? This is technically our I value. So we will use this formula right here and just replace 150 with I. So I'm going to just do the work on this side. We have 150, which is our interior angle, is equal to 180 times n minus 2 all over n. Now when we're solving for these, we are going to be seeing a lot of cross multiplying. So here, same exact thing. Set this over 1, multiply top to bottom, bottom to top. 150 times n is 150n. And then all of this times 1 is just, in fact, all of that. Okay, now before we do anything, I want to distribute, right? I want to simplify this right-hand side. So I'm distributing the 180 to both terms. We get 180n minus, and this is 180 times negative 2, which is negative 360. We didn't do anything to the 150n, so that stays on the left-hand side. Now, I'm just treating n as x. It's a variable. So I want to move my other variable terms to the same side. 150 minus 180 is negative 30n. It's equal to negative 360. So n is equal to 12. So 12, oops, we got it. 12 is our number of sides. Now that we have that, we can fill in the rest of this information. So sum of the interior angles, again, 180 times 12 minus 2. And I'm going to do a little of this in my head, so I'm not necessarily going to write it all out, but I know that 12 minus 2 is 10. So 180 times 10 is 1,800 degrees. Sum of the exterior angles, always 360. We know the measure of one interior angle. The measure of each exterior angle, again using our formula, is 360 divided by 12. 360 divided by 12 is 30 degrees. Okay, now for our last one, we are given in this problem the sum of the interior angles, right? Because it's in that column. So sum of the interior angles. What is that formula? That formula is 180 times n minus 2 equals the sum of the interior angles. We're given s sub I, right? We're given that right away. So we are just going to replace that 1,620 for s sub I. Now we do some distributing, right? Multiply 180 times n, and we get 180n. 180 times negative 2 is negative 360. We didn't do anything to the 1620 on the other side, so we are leaving it alone. What I want to do is add 360 on both sides. Sorry for the lack of room, guys. So we just have 180n left, and we also have 1980 on the right hand side. We still are looking to get that n all by itself. Divide both sides by 180, and we get n is equal to 11. Cool. Now let's fill in the rest of the chart. Sum of the exterior angles. There we go, always 360. Measure of each interior angle. We know the interior angle is 1620. We need to divide that value by our number of sides in the polygon. So 1620 divided by 11 is going to be 147. And I'm just rounding to the nearest whole number. Then we do 360 and divide it by 11. 360 divided by 11, and that is 32 degrees. Okay. Oh, actually, that we have to round that up. Sorry, it was 32.7, so this should be 33. Okay, and that's what we'll do for those charts. You will have a homework assignment with the charts tonight. The rest of these are practice problems. Notice what we are given, whether it's an exterior angle, interior angle, whatnot. We're going to do a few of these problems together. So for number 1, we are given information. It says, what is the measure of an exterior angle of a regular pentagon? Okay, here's our pentagon. How many sides do we have? 5. So I'm just writing out my given information. We know it's irregular, so all angles and sides are going to be equal. And we know that we're talking about an exterior angle. More specifically, 1. So if we're looking back up at our formulas, what is that formula? E is equal to 360 over n. What do we know n is? N is 5. So in our formula where we see n, we are just replacing it with 5. So then it's 360 divided by 5, and we get that exterior angle is equal to 72. Final answer. For number 2, how many sides does a regular polygon have if each exterior angle measures 24 degrees? So we are given each exterior angle. So we know that we're going to be talking again about this formula that we just used. Each angle measure is 24. So E is equal to 24. So we have E is equal to 360 over n. We know E is 24, so we can replace that 24 with E, and nothing else changes. Okay, cool. We have our denominator. We don't want it, though. So let's do a little cross multiplying action. Multiply 24 by n. Multiply 1 by 360. So n is equal to 15. That's our number of sides. So number 3 and 4 are really similar. I'm going to model number 3, and then I'm going to have you do number 4 on your own for practice. And then you'll just get checked off after these notes. So for number 3, these angles outside of our regular or our polygon are exterior angles. We know all these exterior angles have to add to 360. So I'm literally going to be taking each of these angles, adding them together. Oh, we don't know that one. How can we figure it out? These two angles are interior and exterior angles, form a straight line. So they must add to 180 degrees. That's how I know it's 40. Then we continue on, A and 68. We combine all of our like terms to get that A by itself. So subtract 360 from 252, and we get A is equal to 108. So that's what that angle measure. Go ahead and try the other ones.